So in a previous lecture we discussed exact differential equation, and also we discussed how to solve exact differential equation and non-exact differential equation. Then also we discussed how to find the integrating factor. Now in this lecture we discuss a linear differential equation. So first order a linear differential equation whose form is dy by dx plus p of x into y is equal to q of x, or dx by dy plus p of y into x is equal to q of y. So this is a linear form, this is also a linear form. In this equation, y is a dependent variable and x is an independent variable. Here x is a dependent variable, y is an independent variable. So now if the differential equation whose form is this dy by dx plus p of x into y is equal to q of x, or dx by dy plus p of y into x is equal to q of y, then the solution form of equation 1 can be written as y into integrating factor is equal to integration q of x into integrating factor into dx plus c, where the integrating factor for this form is e raised to integration px dx, or suppose this equation is given, then the solution is x into integrating factor is equal to q of y into integrating factor dy plus c, where integrating factor formula is e raised to integration p of y dy. So directly we discuss an example. Example is given dy by dx plus sine x into y is equal to e raised to cos x. So now this equation first we compare with the standard form. Dy by dx plus p of x into y is equal to q of x. So therefore we get p of x is equal to sine x, and q of x is equal to e raised to cos x. So now first we find the integrating factor e raised to integration px dx. Therefore e raised to integration sin x dx, and therefore e raised to minus cos x. And so we input the integrating factor in the solution form. So the form is y into integrating factor is equal to integration qx into integrating factor dx plus c. So that implies y e raised to minus cos x is equal to integration qx into e raised to qx e raised to cos x, integrating factor e raised to minus cos x dx plus c. So e raised to cos x, e raised to minus cos x, so e raised to 0 is 1 and 1 integration is x. So answer is y e raised to minus cos x is equal to x plus c is the required solution of given first order linear equation. Now next example. The example is solve the differential equation dy by dx plus 2y is equal to 6 e raised to x. So again we compare with the standard form dy by dx plus 2y is equal to 6 e raised to x. So we get p is equal to 2 and q is equal to 6 e raised to x. So p is equal to 2 and q is equal to 6 e raised to x. So obviously first we find the integrating factor. So integrating factor is e raised to integration p dx is equal to e raised to integration 2 dx, and 2 dx is e raised to 2x. Therefore, the solution form of the linear equation can be written is y into integrating factor is equal to integration q into integrating factor dx plus c. So we input the all value. So y into e raised to 2x is equal to integration 6 e raised to x, and integrating factor is e raised to 2x. So this is q of x, and integrating factor is e raised to 2x dx plus c. So e raised to x into e raised to 2x is e raised to 3x. So the answer is y raised to 2x is equal to 6 e raised to 3x dx, and then e raised to 3x integration is e raised to 3x by 3. So the required solution is y equal to 2 e raised to x plus c into e raised to minus 2x is the required solution of the given equation. Now, the next important topic is a Bernoulli equation. Bernoulli equation. So first of all, we discuss what is the definition of Bernoulli. What is the form of Bernoulli equation? Which type? So, if the equation of the form, if the equation of the form dy by dx plus p of x into y is equal to q of x into y raised to n. So actually if n is not equal to 0 and n is not equal to 1, then this equation is said to be a Bernoulli equation. This equation is said to be a Bernoulli equation, and indirectly the Bernoulli equation y square or y cube, then equation is a non-linear. So obviously if the equation is a non-linear, that means the Bernoulli, then first we convert in a linear form. And we convert in a linear, then we use the simple procedure for finding the solution of any linear equation. So how to convert this Bernoulli equation in a linear form? So first we multiply of this Bernoulli equation with y raised to minus n. So we multiply y raised to minus n in this equation 1. Then we get y raised to minus n dy by dx plus p of x y raised to minus n into y, that means y raised to 1 minus n, and here only qx. Now we consider y raised to 1 minus n is equal to u. We consider y raised to 1 minus n is equal to u. So this is equation 3. Uh, sorry. 3. So differentiate equation 3, not 2. Differentiate equation 3 with respect to x. Here we consider y raised to 1 minus n is equal to u. This equation we call equation 3. Differentiate equation 3 with respect to x. Here equation is 3, not 2. So 1 minus n, y raised to 1 minus n minus 1, that means y raised to minus n. The derivative of y is a dy by dx is equal to du by dx. So that implies y raised to minus n dy by dx is equal to 1 upon 1 minus n du by dx. So here we know that y raised to minus n dy by dx. So this term we replace this form. So suppose we call this equation is 4. So input equation 3 and 4. We get dy by dx is replaced with 1 upon n 1 minus n du by dx. This term is a replace. That means this term is a replace with 1 upon 1 minus n du by dx. Y raised to 1 minus n is a replace with u. Okay. So 1 upon 1 minus n du by dx plus p of x into u is equal to q of x. Now multiply with 1 minus n, then du by dx plus 1 minus n p of x into u is equal to 1 minus n into q of x. And this equation is 5. So equation 5 is a linear differential equation in u and x, where u is a dependent and x is a independent. And suppose this is a linear equation, so obviously the solution form we discussed previous, u into integrating factor integration 1 minus n, that means this term into integrating factor dx plus c, where integrating factor is a e raised to this form dx. After finding the solution of this equation, we replace u with y raised to 1 minus n, then we get the solution of given equation. Now we discuss the example. So we consider a simple example, dy by dx plus 1 upon x into y is equal to x square y raised to 6. So first we compare this equation with the standard form. So this value is a p of x. This value x square we compare with the standard form. So p of x is a 1 by x, q of x is a x square, and the y power is 6, so n is equal to 6. Now n is equal to 6. So first we take, that means this equation is a Bernoulli equation, we convert in a linear form. So we consider u is equal to y raised to 1 minus n. So y raised to minus 5 because n is 6. So u is nothing but y raised to minus 5. Now in the previous slide we know that what is the linear form of the given Bernoulli equation. So the linear form is a du by dx plus 1 minus n into p of x into u is equal to 1 minus n into q of x. So we know that this is the linear form of the standard equation, standard Bernoulli equation. Okay. So we use this for equation. So du by dx 1 minus n p of x into u 1 minus n q of x. That implies du by dx 1 minus n. So 1 minus 6 is minus 5, and p of x is 1 by x. So minus 5 by x into u, and 1 minus x is minus 5, and q of x is x square. So we get this equation, and this equation is indirectly a linear first order equation. So now this is a linear first order equation. So we find the integrating factor. So integrating factor is a e raised to integration 1 minus n p of x dx. That means e raised to integration minus 5 by x dx. That means e raised to minus 5 log x. So x raised to minus 5, and therefore x raised to minus 5 is 1 upon x raised to 5. So x raised to minus 5 is 1 upon x raised to 5. So the integrating factor is a 1 upon x raised to 5. Now we know that the solution form. So u into integrating factor is a integration 1 minus n q of x into integrating factor dx plus c. So u into 1 upon x raised to 5 is equal to 1 minus n into q of x is a minus 5x square into integrating factor 1 upon x raised to 5 dx plus c. That implies u into 1 upon x raised to 5 is equal to minus 5 x raised to minus 3 dx. And x raised to minus 3 integration is x raised to minus 2 divided by minus 2. Then we get 1 upon x raised to 5 into u is equal to this form. Now u is replaced with y raised to minus 5. So 1 upon y raised to 5 is equal to minus minus plus, so 5 by 2 x cube plus c x raised to 5 is the required solution. Now we discuss the next example, dy by dx plus 1 upon x into y is equal to y cube. Here in the right hand side the power of y is not equal to 0, not equal to 1, so obviously this equation is a Bernoulli equation. So we compare with the standard form, then we get p of x is 1 by x, q of x is 1, and n is 3. So the substitution u is equal to y raised to 1 minus n. Therefore y raised to 1 minus n, n is nothing but n is 3. So 1 minus 3 is minus 2. So u is equal to y raised to minus 2. Now the linear form of this a Bernoulli equation is du by dx plus 1 minus n into p of x into u is equal to 1 minus n into q of x. So that implies du by dx plus 1 minus n into p of x is a minus 2 by x into u is equal to 1 minus n. That means 1 minus minus 2 q of x is 1. So minus 2. Now this is the linear equation. So the integrating factor is e raised to integration 1 minus n p of x dx. So e raised to minus 2 by x dx. So e raised to minus 2 log x. So we get the integrating factor is 1 upon x square. Now we know that the solution form, we replace integrating factor is 1 upon x square. So answer is u into 1 upon x square is equal to integration 1 minus n, that means 1 minus 3, that means minus 2, q of x is 1 into integrating factor is 1 upon x square. We write x raised to minus 2 dx plus c. So that implies u into 1 upon x square is equal to minus 2 by x square. And 2 by x square integration is a 2 by x, because we know that 1 upon x square integration is minus 1 by x. So minus minus plus, so plus c. And then we get the solution is 1 upon u is a replaced with 1 upon y square. So answer is 1 upon y square is equal to 2x plus cx square. This is the required solution of the given Bernoulli equation. Thank you. So today we discuss two topics in this lecture. First is a linear equation, how to solve. Second one is the Bernoulli equation. Bernoulli equation is indirectly the non-linear equation. Using the substitution, we convert nonlinear in a linear equation, and then we use the method for finding the solution of linear equation. So thank you. Now in the next lecture, we discuss the application of the first order ODE.